Yes, good afternoon, members, and welcome to back to our class on continuation of prime factorization. Last time we looked at prime factorization, where we learned how to solve some mathematical on factorization. We also define on what's a factor, what's a product, and what's a prime number. So in our last class, we looked how to solve a factor using prime factor tree. For instance, with me here, I've got 27, in which 27 can be divided by 3 to get 9 by 3 to get 3, and 3 can be divided by 3 to get 1. Hence, our factors will be 3 multiplied by 3 and multiplied by 3. Or in other terms, we say 3 raised to power 4. Another one is 12. You can divide 12. Start from the smallest value that can divide that factor. And the smallest factor is 12, 2. So when you divide 12 by 2, you obtain 6. You divide 6 by 2, you obtain 3. And then you divide 3 by 1, you get 1. So in other terms, you write as 2 raised to 2, which is 4, multiplied by 3. 2 raised to 2 multiplied by 3 is equivalent to 12. Okay? Our next example is 18. The smallest factor that can divide 18 without a remainder is 2. If you divide 18 by 2, you get 9 without any remainder. So our smallest factor will be 2. 18 divided by 2, you get 9. 9 divided by another smallest factor that can divide 9 is 3. You divide 9 by, you end up obtaining 3, and then 3 divided by 1, you get 1. So our factors will be 3 multiplied by 3 multiplied by 2, of which 3 multiplied by 3 is equivalent as 3 raised to 2 multiplied by 2. 3 is equivalent to 9, then 9 multiplied by 2 is equivalent to 18. Is it well understood, class? Class, the following screens, as I've shared my screen, the following screen illustrates another method that you can use to find prime factorization of a composite number. Remember, a composite is a number that has more than 2. Let's look at the other method. It's called a method. Step 1, write any composite number, a number that has 2 factors. For instance, with me, I choose 18. It has more than 2 factors. Our thing is you start dividing by the prime, which is, remember, you start with the smallest factor, which can divide 18 without a remainder, which is 2. If you divide 18 2, you will get 9. That's step 3. Step 3, the factors If they are prime, proceed to step 6. If not, continue with the process. So 18 divided by 2 is 9. 9 can be divided by a small number which is 3 to obtain 3. 3 is a prime, so we will not continue to the next step. So 3 divided by 3 to get 1, so it will be 3 squared multiplied by 2 to obtain 18. Is it understood, class? Let's look at step 6, which I've summarized. We write the prime factorization in exponential form. In exponential form, when I say exponential form, I mean raised to a particular number, or in or what do we call integer, raised to a particular integer. So we have the factors of 18 is 2, 3, and 3. 2 times 3 multiplied by 3. But 3 and 3 are common. You raise to power 2 to get 3 raised to 2 multiplied by 2. 3 raised to 2, 3 is equivalent to 3 squared, which 3 squared is 9. And then when you multiply the 9 by 2, you obtain 18. Good. Yeah, an example of 56 is a composite number because that's more than 2 factors. So let's start with step 1. We identify the smallest number that can divide 56 without a remainder. So our smallest number is 2 divided by 56. 56 divided by 2 class is 28. Smallest factor that can divide 28 without a remainder still is 2. 28 divided by we obtain 4, and can divide 14 without a remainder. It's 10 can divide 14 by 2, 7. 7 is 7 a prime? Yes, it is. So you will divide 7 to obtain 1. So what's our factors? It will be 7 multiplied by 2 multiplied by 2 multiplied by 2. Remember, you choose the common and write it in a power form. For instance, our 2 is 3 times, so it will be 2 raised to 3 multiplied by 7. 2 raised to 3 is equivalent to what, class? 2 raised to 3 is equivalent to 8. And then you multiply 8 by 7, you obtain 56. Good. So class, let's look at the summary of what we have been learning all through. Our first summary is, first one is not a prime or composite number, isn't it? A prime number is a number that can be divided by itself without a remainder, and 1. 1 cannot be divided by 1 and get a When you divide 1 by 1, you will obtain 1 and a remainder of 1. So it's not a prime number, and again, it's not a composite number because composite number is a number which has more than. Also, 2 is only even prime number because 2 can be divided only by 2 and 1, isn't it? And then class, what you need to know is that not all odd numbers are prime. Example, 9 is not a prime number because it can be divided by 3 to get 3. It can also be divided by 9 to get 9 and 1 to get 9. And we say a prime number is a number that can be divided by itself and 1 only. 15 can be divided by 5 and 3. 21 can be divided by 7 and 3 and 21 and 1. 27 can be divided by 9, 3, 27 and 1. Like to 33, same case to 33 and 35. Our last, all composite numbers can be written as product of prime number. So that's marked the end of our today's class. Thank you, class, for your cooperation. In our next class, we are going to introduce our new topic, which is fraction. Otherwise, I don't have much to say, but to wish you a nice weekend till Monday when we meet. Thank you.